gravity pulls things together. If you look at the universe expanding outward from the Big Bang, you'd expect the immense gravity of all the stars, planets, and gas to eventually slow that expansion down. It's an intuitive rule. Toss a ball into the air, and eventually its own weight pulls it back. In the late 1990s, two independent teams of astronomers decided to measure exactly how much this cosmic deceleration was happening. They wanted to calculate the breaking speed of the universe. To do this, they relied on distant supernovae. These exploding stars have a very consistent intrinsic brightness, which allows them to act as standard candles. By measuring how dim they appear from Earth, astronomers can determine vast cosmic distances with extreme precision. But the data they got back completely defied expectations. The supernovae were much dimmer and therefore much farther away than any gravitational model predicted. The universe is not slowing down. The expansion is speeding up. Something is pushing space apart, entirely overpowering the inward pull of gravity. That single observation broke a century of assumed astrophysics. It revealed that an invisible mechanism is dominating the motion of the cosmos, accelerating the expansion rather than curbing it. We call this mysterious phenomenon dark energy. It exerts a negative pressure, a repulsive force woven into empty space. Unlike normal matter, which thins out as the universe expands, dark energy does not dilute. Space grows, but its density remains exactly the same. The idea that empty space possesses a repulsive force actually traces back to 1917 with Albert Einstein and his proposed cosmological constant. Einstein originally added this constant to his equations as a mathematical fudge factor. He wanted to force his models to describe a static, unchanging universe. When he later learned the universe was actually expanding, he abandoned the constant, calling it a massive mistake. Today, that discarded mistake has returned as our leading explanation for dark energy. The mathematical placeholder Einstein invented perfectly describes an intrinsic, unchanging energy native to empty space. While trying to invent a way to keep the universe perfectly still, the greatest mind in modern physics accidentally predicted the exact force driving its ultimate acceleration. This brings us to a major crisis in theoretical physics. According to quantum field theory, a perfect vacuum isn't truly empty. It seethes with temporary particles popping in and out of existence, creating what we call vacuum energy. In theory, this vacuum energy should act exactly like Einstein's cosmological constant, providing the outward push needed to accelerate the universe. This chart illustrates a staggering discrepancy. When plotting the tiny observed value of dark energy alongside what physicists calculate the vacuum energy should be, the theoretical prediction shoots violently upward by a factor of 10 to the power of 120. That calculation is off by an almost incomprehensible margin. It is widely considered the worst theoretical prediction in the history of physics, and right now, nobody has a satisfying explanation for it. This discrepancy leaves our fundamental theories at odds. The math that describes the cosmos and the math that describes the vacuum simply refuse to agree. This pie chart shows dark energy's dominance. 68% of the universe is dark energy, squeezing matter into a minority. Transitioning to a timeline, 5 billion years ago, space expanded and diluted matter enough that dark energy overtook gravity. Because of this takeover, distant galaxies are receding at ever-increasing speeds. Eventually, they will move away faster than light can travel to bridge the gap. This leads to a future of cosmic isolation. Those distant galaxies will fade from view completely. Light from the wider universe will never reach us, leaving our local neighborhood forever stranded in the void. Depending on exactly how this acceleration behaves, the cosmos faces a bleak final act. It might result in a big freeze, where everything drifts apart and grows completely dark, or a big rip, where the outward push becomes so extreme that it tears apart atoms themselves. To find out which fate awaits us, astronomers are building massive next-generation instruments to study this force before our observational window closes. Our night sky is destined to go completely black. The ultimate fate of everything we know hinges entirely on an invisible energy we still barely comprehend.